Okay, let's go ahead and talk about the settings tables. This is really at the heart of where Minion reindexing gets its power. So we're going to go ahead and start with the settings DB table, and that's the settings database table, right? Which means that these are the settings at the database level. I'm going to go ahead and drag this up here if I can. Okay, so the first thing you're going to notice is we have a Minion default database, and this is where all of the databases get their default values from. So when you run the job that does the reindexing, you don't have to pass in parameters for reorg threshold or fill factor or rebuild threshold or any of that stuff. You do it right here. So any database by default will run with these values, and you'll notice that we have every single index option available to you. If it's available in the reindex or in the alter index statement, it's available in this table. We haven't shortcutted anything at all. So reorg, or I mean the reindex order and the group order, we'll talk about that. The reorg threshold and rebuild threshold, the fill factor, online, max dop data compression, whether or not to get the row count of the table, whether or not to get your fragmentation level after the reindex is done, whether or not you want to update the stats when you do a defrag. It's a good idea, that's why I default to it. Stat scan options. So in your update statistics statement, this is going to be anything that comes after the with. So with full scan would be a good example of that. So in here you would put full scan and it would do a full scan on your table. So any of those options are wide open to you in here. Just do them exactly like you would in the statement. I provide the with for you and you put everything that comes after the with. Whether or not you want to ignore the dupe key. We even have all of the 2014 options here. Wait at low priority, max duration in minutes, abort after wait. Also, log index physical stats. You're not going to use this one very often, and as a matter of fact, most of you probably won't use it at all, but it can be a really good troubleshooting tool. Let's say that you want to be able to inspect some of the deeper level stats in the from the index physical stats DMV. Well, when the reindexing runs, if you set this to 1, I will actually save those off in a table in the Minion schema for you. And then you can go back and you can look at them at your leisure, and you can see what those extended stats were. So it may help you troubleshoot some issue. It may help you inspect your indexes a little bit more. Now, right now you have to do a manual deletion of those rows in there, which is why I don't turn it on by default. So if you use this, don't forget to go back and clean up after yourself. The index scan mode, you can default to limited or detailed. Any database pre-code that you want to run, right here I'm just doing a delay of 4 seconds so I can have something to show. Anything you want to run after the reindexing. And any pre and post code at the table level. So every single table that gets processed will run this pre-code or this post code. Whether or not to log the progress, there's going to be a separate video on this, but this is an excellent feature that we absolutely love. What this does is it allows you to not have your reindexing be a black box operation. I've been in many shops where we've had huge databases that we were trying to reindex, and after 2 or 3 hours, especially during a maintenance window, you have no idea what it's doing. And you've got the operations guys asking you, hey, where's this reindex? What's going on? How far along is it? When is it going to be finished? And you have no idea because the reindex is just running, and well, it'll finish when it finishes. So log progress logs every single thing that the reindex does in live mode so that you can go to the log tables and you can see exactly where it's doing, where it is and what it's doing, and you can watch it progress through the tables and the indexes that it's got to process. Not only that, but we also provide you a query that will help you estimate how much longer it's going to take to get through the routine. As long as you've run the reindexing before, then we have stats because we base it off of the previous runs of those indexes, and we basically use those previous runs as a good estimator for what this one is going to take. So we allow you to not only see the progress, but we also allow you to estimate how much longer it's going to be. That's a very powerful feature. Log retention days. How many days are we going to keep the data in the log? And then two last ones here. Recovery model. I really like setting my databases to bulk logged for reindexing operations. So if you have a large database and you know it's going to blow out your log, then go ahead and set it to bulk logged. When the reindexing is done, it'll set it back to whatever it was before. And include usage details. What I do is I pull the stats out of the usage DMVs, out of the index usage DMVs, and show you all of the seeks and scans and updates from those DMVs so that you can get a good idea of how much your indexes are being used, especially how much they're being used over time. So this can be a really nice feature just to help you investigate your index usage over time. Okay, so that's an explanation of most of the columns. I think some of these other ones in here, ignore dupe key and stats no recompute, those things are self-explanatory, and if they're not self-explanatory, then they're well documented in MSDN. So that's the Minion default. This row has to be here or the reindexing will not run, because this is where everything gets its value. But let's say you wanted a database to have a different value. You wanted to have different rows. You wanted a different reorg threshold or a different rebuild threshold or a different default fill factor, right? Well, just enter in a new row for that database. You don't have to create a new job and pass in new parameters. And if you have, 20 different databases and you want them to have 20 different settings, you don't have to have 20 different jobs. You just enter in a row in this table and you're done. And it's the exact same reindexing job. It picks up the new settings the next time it runs and you're off. Not to mention, making changes this way, keeping them in a table, makes it a lot easier for you to make mass changes across multiple environments. With Group Server Query and Management Studio, with PowerShell, you could write a single update statement and you can update the reindexing settings for hundreds of boxes all at once. And it's just that easy. One thing that you need to be made aware of, though, is once you enter a database in here, it no longer gets any settings from the default. All of its settings come from here. So if you want all of the settings in your database to be the same as the default except for one, let's say I want to change this to 30 instead of 15, right? And everything else is going to be the same, you have to duplicate all of the settings from here down here. All of the settings come from this level now. And if you think about it, that really makes sense. I have no way of interpreting your intent. If one of these values is 15 on one and 25 on the other, how do I know that you didn't just fat finger it for a 25? Right? How do I know that you didn't intend to put 15? If there's a value here that's null and another value is off, or this value is off and this value is null, how do I know that you just didn't forget to put the off in there, or you meant to put on, or how do I know what your intent was? So, in order to keep from messing things up and trying to guess your intent, which is absolutely impossible, you have to take all of your settings from this second row. Now, this is also where you're going to exclude a database. You have two ways to exclude a database. This is my favorite. So if I want to turn off a handful of databases from being reindexed, all I do is say exclude equals 1 right here, and it's that simple. And I'm going to talk about reindex order and reindex group order and reindex order in a different video, but the basics here are you can reindex the databases in any order you want to, simply by playing with these numbers in here. And I'm going to tell you the higher number wins. So simply, if I want to reindex this one before I reindex all the other databases, I would put a 1 in here. The higher number wins. It's a weighted priority. It's not a priority necessarily, it's a weight, right? So the bigger number wins. If I want to make this one a lot higher than anything else I would want, I could put this at 100 or 1,000 even, and then all of the other databases could fall in line after it. And I'll explain reindex order in the other video where we actually talk about the ordering of the databases. So okay, that is the settings DB table. Now to make a change, I simply make an update, right? If I want to change the default for all the databases that don't have their individual rows in here, then I just run this reindex statement. Let's go ahead and change this to reorg equals, let's see, what is it, 5 now? Let's make it 10. And let's make the default fill factor 85. not 850, 85. There we go. For Minion default. Boom. Now when I run this again, you can see I've got my new settings, 10 and 85, and I'm done. And I could take that exact same thing and I could put that in PowerShell, or I could put that in Group Server Query, and I could change the default settings for my entire environment if I wanted to in just a few seconds. It's very, very powerful. I love that feature. Okay, now we've got the exact same thing at the table level. So that's the settings DB. Now I've got settings table. And this exact same thing holds true. This has all of the columns, or almost all the columns, that the other table has, and a couple extras, right? So we've got the database name, the schema name, the table name, and everything else is the same. The only thing that I don't have in here, you notice how I have the table pre-code and the postcode, but I don't have the database pre-code and postcode, because this is at the table level. It doesn't really, the database code isn't really relevant at this level. But where you would do something like this is, let's say that I've got my database defaults, whether a database has its own row in the database, in the settings DB table, or whether it's getting them from the Minion default, you can still override that at the table level. So let's say that I've got the reorg threshold set here at 10, and I've got the rebuild set at 25, but I want this one table over here to be at 20 and at 45. Well, all I got to do is enter in a row here in this table. There we go. And you can see here now this guy will be reorged at 20 and it'll be rebuilt at 45, while the rest of the database, here I'll go ahead and push all this up. There we go. So this is in the demo database. And so the rest of the database, since it doesn't have a row here, will get its data from here, and the rest of the database will get their settings at reorg at 10 and rebuild at 25. And you notice also that I don't have a fill factor specified here, whereas I do have a fill factor specified at 85 here. So this is for a number of reasons. So I did this for a very specific reason, and that's to show you how this works. If a value in any of these tables is null, then it won't be included in the reindexing statement and the defaults will kick in. So let's say that this table, this offline clustered table, has a fill factor of, oh, I don't know, let's say 65, right? It's a very special table. It needs a 65% fill factor. Okay, fine. I could put it in here as 65. Or let's say that all of the indexes on there, each individual index has a separate fill factor. I've seen that as well too. And you just don't want to mess with them because the table level is as low as we go. I don't really go down to the index level, so you can't really specify a fill factor at the index level. You can only do it at the table level. So if you've got 12 indexes on there with 3 different fill factors, if you leave this null, they will keep their original fill factors. Fill factor won't even be an option here. It won't even show up in the reindexing statement. So they'll all keep the fill factors that they already have. So that's a really good way of preserving something. If you don't want to mess with it, it's a really good way of preserving that. However, if that table has a 65% fill factor across the board, all of the indexes have that same fill factor, then you're, of course, welcome to put in a 65 right here and you'll be just fine. So this works the same way that the database table works. If there is a row in here for an individual table, every one of that table's settings will come from this row. It will not come from the database table anymore. So it doesn't inherit anything. It pulls its own rows and it's 100% independent at this point. So, and you'll notice the power that we have here. I get the row count on a per table basis. I get the post fragmentation level at a per table basis. That also means that I can set my update stats on defrag or my stat scan options, right? It also means that I can choose to log index physical stats at the individual table, my index scan mode. So that again would be, if we're going up here, that would be either limited or detailed. And if it's null, it's limited, just like it is in the index physical stats table. So here I'm going to do the same thing as I did up there, but I could make this a detailed pull instead. And if I want a different table pre-code to run here than I do for any of the others. Or as a matter of fact, what's more likely, it's less likely that you're going to run pre and post code for all the tables. You'll probably, if anything, want it run for just a single table. So you would add a row in here, make everything else the same, and then add your table pre-code or post-code, and then it'll run that pre or post-code just for that individual table. I can log the progress for just an individual table. I can store different tables in the log for different periods of time. So you can see here at the database level that I've got my log retention day set at 60. I would clearly want to put something in here for log retention days. Maybe I want to keep this table a little bit longer, or maybe this table isn't very important and I want this table to only be kept for a week or a month, or maybe I want it to be kept for a year, right? So all kinds of things, and also whether or not to include the index usage details for this individual table. So not only can I do all of this in a single job, but I can also get down to the table level settings in an individual job, and I don't have to make different calls, and I can make mass changes with a simple update statement. If I have an application with several environments, let's say that my big application has a prod, a dev, a QA, a test, a pre-prod, whatever number of servers that you have, and it has this database and these tables and this one set of tables in all of these databases, and maybe your developers keep trying to do schema compares, and these schema compares keep failing or keep showing differences because there are differences in, say, fill factors or pad index or something like that, then you can very easily standardize these across all of your servers with a single update statement. All you got to do is put it in a group server query or in a PowerShell, wrap it up in a PowerShell and point it at all those boxes, and you can make that change across the board with no problems with a single update statement and make sure that they're all the same. Very powerful stuff. Okay, so that's it on the settings tables. There will be some individual videos to come out on some of these individual features because there's a little bit of nuance in some of these, and you can do some pretty cool stuff. So I'm going to break these up, but this is the high-level view of it all.